Good afternoon, good evening, and very early good morning to you, wherever you may be. This is our July Automation User Group meeting, and we've got a fun evening, morning, or afternoon planned for you with a number of excellent presentations. So we have me talking rubbish for about 5 minutes. We're then going to have Grant Orchard, who's very kindly joining us from completely the other side of the world. So he really should be in bed right now, but hopefully he's going to talk about something super awesome. At least, well, we hope he is. We also hope to have Krisztian Kuklis joining as well. So he's going to be talking about integrating vRealize automation with ServiceNow. And we are going to be finishing up a little earlier than planned this evening with Katarina Brookfield, who's going to be covering some of the work she's been doing recently around Kubernetes and getting started with that. And it's a session I'm quite looking forward to. We did have a fourth session planned. Somewhat unfortunately, the person needed to back out, unfortunately. So that's why we're finishing a little early. Which brings me on to a good point. Do you want to share? Do you a specialist in a particular solution or a technology, and are you willing to talk about it? Is it relevant to automation? And would you like to present at one of our future meetings? If so, please feel free to get in touch with us. Probably best via Twitter. So we have a number of accounts listed there. The user group has its own account. Robert, Mark, and myself all have our Twitter IDs listed there. And of course, you can contact us through the website that we have. There's also a forum there to discuss various interesting things. Our next meeting is, and I forgot to put the date in, sorry, I've literally come from another meeting. Bear with me 2 seconds. 21st of October, we were planning to have our next meeting. I might even stick that in there. 21st of October is going to be our next meeting. So if you do want to present something, then yeah, get in touch. We'd love to have you on. Be fascinating to have something different to talk about and listen to. But without too much further ado, I'm going to hand it over to Grant so he can get to bed at a vaguely sensible time and let him talk, basically.
Brilliant. I love talking. Talking's great. Yeah, thanks guys for having me on. Look, I see you going on mute there, Michael. I'm going to say don't go on mute. Maybe yourself, Robert and Mark, since you're the leaders of this, can hang off mute for a little while, because I'm taking the session in a slightly different direction tonight. Originally I had some grand plans of sort of, showcasing a whole bunch of cool demos and stuff. And I thought, that's kind of fun and all, but you're probably not going to walk away with, any actual value out of that, apart from going, hey, that stuff looked cool. So instead, what I wanted to do was actually have a bit of a discussion with you about what I've learned over the last couple of years being at HashiCorp, and how being here sort of shaped the way that I've rethought about automation, as in very broad brushstrokes. And so I'm going to take us into a bit of a whiteboard pitch, not a pitch, gosh, a whiteboard session via the iPad, where I'll just sort of talk about stuff, and as interesting things come up, I want you guys to sort of interject and ask questions. Now, by all means, everybody else on the call is also very welcome to come off mute and ask their questions or throw them into chat. But I'll bounce around, and as things, potentially go a particular way, I've got some sort of, interesting code samples and things in here. Got a few diagrams that'll hopefully help in anticipating some of the questions we might get. And I'll just sort of flip in and out of that. Yeah, anyway, let's kind of roll on with things. So you'll see things in slightly yellow mode. That's my iPad saying it's late and turning off blue. But I think, the first thing to kind of get across is where the industry's been going from a technology perspective, because this kind of lays the bedrock, right? And I think, looking at most of the faces on the call, I recognize an awful lot of you. And you all started in the same place as I did, which is sort of sitting in, a private data center, working on, vSphere environments, working within heterogeneous technologies. You've got, load balancers, firewalls, a whole bunch of stuff that kind of sits within there. You've got this defaulting. Is that mirroring, or is that looking all right on your screen?
It's okay.
Mirroring on my side. There we go. Thank you.
Looks kind of mean.
Yeah. All right. And so I think like the shift that we've all seen going on, that's not a penis, that's an arrow. I'll just kind of sharpen up the tip there. The shift that we've all seen going on is kind of, that data center is sure as hell not going away, right? In some cases, even it's moving onto, cloud platforms, things like VMC and AWS, the VMware Azure solution, Azure VMware solution, so on and so forth. That's certainly not going anywhere. It's definitely going through like an evolution. But, the reality is for almost every customer, they're starting to layer on top, different public cloud platforms of choice. So that's kind of like the underpinning technology trend. When we look at and we think about automation, it's like, right, how do we come in and look and try and find a way that's, way to automate things that's going to translate across here? And so this is where one of the very first sort of, principles or Tao of HashiCorp comes from, which is, and I will write this so that we can come back to it if we need to, but it's basically the idea of workflows, not technology, right? And it's like this idea that we don't want to get too opinionated about, the technology stack that we're using, but what we need to sort of try and find is a way to build a workflow that's going to translate, right? That's going to scale, because ultimately, I think that's what sort of underpins the heart of everything we do, which is, automation is about a few things. It's about, consistency and reliability, being able to make sure that you get the same thing every single time. It's about speed, and it's also about ability to scale. So most tooling that you find in the automation space sort of acts more as like a lever to other technologies to make them more efficient. So we look at the world kind of that way. And I think one thing that's really interesting, we talk about a cloud operating model. And so for us, it's really this idea of what does the intersection of, the technologies and the trends that are going on look like when it kind of collides or intersects with the processes that you have in an organization, right? So like if we think of, traditional models of, hey, if you want to get the needed infrastructure to, deploy your application, you're going to say, I need a virtual machine. So you reach out to one team, and then you need, a set of firewall rules. So you reach out to another team. Then you might need load balancers. You might need sort of certificates. And, that process can take, depending on how well you've got things automated, it could take a short time. It could take a really long time. But ultimately, the reason why this becomes important is, the process here and the agility that you're looking for is actually underpinned by the processes and the way that you build the relationships between those. So if you were to say, if you were talking to some senior executive at your company and they say, yeah, look, what we're trying to do is adopt public cloud. And you said, yeah, okay, so we've got all these manual processes, this here takes somewhere in the vicinity of 22 weeks to get to. If we want to add, who knows, Azure Key Store or something off the back of that, and we just threw Azure on here and said, okay, now it's going to take 24 weeks. Typically, you're not actually succeeding in the whole idea of, adopting public cloud, because that is not the goal, right? Kat's coming in to talk about Kubernetes. In reality, adopting Kubernetes is not the goal, right? It's just kind of the underpinning of how you get to the thing that's actually particularly meaningful. And so this is where like the intersection of technology and process is, what we call the cloud operating model. A lot of people call it, a lot of people have cloud operating models, but thought sort of settling on some definitions to start that up front would be kind of useful. So if we want to optimize the process, because that's the challenging part, I think what we want to do is, I think the people don't go away, and we look at this, and typically the way people are doing this at the moment is, ITIL, ITSM, whatever you want to call it. So you've got later on, I think you're doing a vRealize ServiceNow thing. ServiceNow is pretty big in this space of, logging your ticket, handing stuff off between different teams, how you handle the change management and so on, and getting to a point where that's all automated is like super, super critical. So I think a kind of old world view, and not taking a pot shot at ServiceNow, but like the old model of how you did ServiceNow or ITSM, where it was like log a ticket and wait and, just nothing happened. That was problematic. But if we looked at the idea of saying, you've got your dev, or you've got, I don't like calling them users because it sounds like they're druggers, but if you've got, your development team or whoever it is that's actually trying to build stuff, they still need a way to get to that infrastructure, right? And typically, there's some people over this side who we call ops. And the big misnomer is this idea that DevOps is the collapsing of the two teams, right? That's just not the reality. Pushing more stuff out of ops to the development teams, giving them more responsibility, also not good, because they're not focusing on their core skills. What we're really looking for is this idea of how do we build a new way of those two teams to actually interact. And I think, if we draw on, the broader industry again and look at the evolution of what's happened with regards to, microservices and the way software's evolved, there's some really interesting patterns there that we can mimic. So what we want to do instead is say, look, yeah, we still need some kind of system of coordination, in effect, to allow these teams to work together. But what we actually need is sort of, a northbound API that the development team can hit, and a sort of southbound API that the ops teams can sort of publish stuff into, in order to say, well, right, the things that you want, you can just, basically self-serve and give yourself access to. So at its heart, when we look across everything that I've been working with over the last 2 years, it's a question of how do we build this idea of, self-service, all the way through the life cycle of automation. So really quickly on that, I think, the idea of self-service as well, just because words are hard, and English is particularly hard. Sometimes we look at self-service and think, okay, so, when we say self-service, what do we mean? Does it mean, that we've got a catalog, basically a shopping cart of things that, somebody has pre-made for us that we want to be able to make use of? Sure, yeah, absolutely. That's one part of it. The idea of self-service consumption is definitely one part. But I think the other part that we quite often overlook is the idea that we've actually got sort of, power users within our organizations. And when we talk to them about self-service, they're like, actually, what we want is the ability to self-serve, the creation, the actual creation of this stuff over here. I don't want Mark to create stuff for me. I don't think anybody wants Mark to create stuff for them. I actually want to be able to create it by myself. I'm using things that, potentially you don't have expertise in. And so I want to build it myself. So if I was to, like, as an example, come over here and say, all right, what if, this isn't the ops team anymore, or, they're a subset of the ops team, maybe they're, the networking team. And maybe what they're able to do is come in here and say, all right, I have the specialized expertise to understand how things like, F5 work, or, NetScalers, or, some other particular network device, whatever it might be, giving them the ability to sort of describe, in effect, an interface and a model that can then be published out here. That idea of, giving them that capability, because ultimately when we start talking about specifically the agility side of things, the minute that we sort of bottleneck on a single team being responsible for the creation of everything that exists there, you're not only bottlenecking the speed at which you can build stuff, bottlenecking in terms of the expertise, you're also bottlenecking the creativity of what can actually sort of come out of this kind of process. So I think that's a really interesting area to sort of delve into. And again, even if we come back, if we talk about, the data center on this side of the wall, right? Not the data center of, years gone by, but, the data center of now, there really is just a huge amount of technology, right? And so when we start talking about automation, the idea that, you can bring in teams with, their own specific focus, instead of needing to have, 500 people who, that's a massive exaggeration, instead of even have a team of 20 people who are just managing firewall changes. Imagine if you could have a team of 3 people who really understood stuff incredibly well, who sort of built a lot of the automation codified mechanisms for interfacing with those, so that they could actually scale out significantly and move on to other projects and do more useful things. So big one there is this idea of what does self-service actually mean? Definitely moving beyond the idea of just self-service consumption into self-service creation, the ability to self-service auditing. And I think where things start to get particularly interesting is in the world of day 2, right? And I'll come back to that one momentarily. So across the stack, what you probably know HashiCorp for would be what we do in the provisioning space, Terraform being a big part of that, Packer as well. And I think you've done a couple of sessions on Packer already, right, boys?
Yes, we certainly have.
Nice. So as we sort of move up the stack into sort of the security space, we've got Vault sitting here. Console takes on sort of the connectivity area. In the runtime's actually a pretty interesting thing. Again, depending on how we go for time, we might talk about this a little bit, but when I talk about runtime, that could be Google Cloud Run, it could be Lambda, it could be Kubernetes. Once you've actually got your code, how you choose to execute it, what the runtime actually is for that. And to be honest, that space, if I throw Waypoint in here as well, probably that point at the moment is probably the most diffuse area of everything that's going on right now, because we're seeing abstractions built on abstractions, and we're getting to the point where that's the question is, what's the right interface for development teams actually to be hitting. And I know we're recording this, hopefully I don't get in trouble, but to me, Terraform, Packer, they're not really the actual spot for the developer interface. They want to be writing their code, they want to commit it, build the artifacts, deploy, release, etc. So that kind of fits in a lot more up there. So I think the best example I can give of day 2 really starts to fit into when we're talking about something like Vault. So for those of you who haven't touched this at all, that triangle is kind of the logo for Vault with some other bits and pieces in there. Vault is what we call in the market basically secrets management. So it provides a place for you to securely store within a cryptographically sealed space things like usernames, passwords, API keys. We can do things like disk encryption, right? So if you're doing things like vSAN disk encryption or vmcrypt or whatever it might be, you can actually leverage something like Vault to provide that external key service as a mechanism for that encryption. So anything to do with basically authn or authz kind of lives over here. And when we start talking about data, probably we can talk about data in transit or data at rest, right? But I really want to talk about like the day two concept, right? And I think this is kind of cool because when I start to think about where the biggest changes have occurred to me, it's really been around this idea of self-service, but not in the way that I just described. There's not only like the concept of what is self-service, but the idea of who is it that's actually trying to serve, right? Like who is the person who's initiating this thing, who's, you know, the person who actually needs to get access to these resources, because that becomes super, super fascinating. Now, let's imagine, all right, let's get one of you into, all right, Robert, you're off mute. Robert, imagine that you needed to get an account for, you know, some AWS testing that you were doing, right, at VMware. What would be the process for you to like typically do that ish? Just very, very high level guidelines.
Probably log into the portal and just deploy an instance or whatever. So
you've already got IAM credentials at the moment. So like if you imagine you don't have credentials at all, like would you have to like go to security, or what does that look like?
I would never go to security. They hate me already, you know. So I'm on speed dial for most security departments. But yes, so yeah, go to the department responsible for it in normal organizations, and then request access. And remember to bring candy.
Yeah,
that's how
perfect. Perfect. All right, so like at some level, effectively, like what I guess if we describe sort of that flow, right? So, whoops, that's not erase. That's erase. All right, so over here we've got Robert. So he would reach out to the department and say, "Hey, I'm trying to do some stuff with VRA on AWS, and I need an account." And you know, they'd basically go, "Okay, cool. I'm going to log into AWS. I'm going to create some IAM credentials, and then what I'm going to do is actually pass those back to you, Robert." And then Robert comes over here and is able to log into AWS, you know, using VRA or whatever he's using.
In real world, that's when it doesn't work, and I go back to the security department. Okay. Yeah, but a week later, yes.
Perfect, right? So that's like the kind of standard pattern of what this looks like. And then, of course, you know, some time passes. Robert tries to log in, it doesn't work, and he calls up and they're like, "Oh yeah, look, we've got a security policy that says, you know, after 3 days that password should expire." So yeah, no surprises. All right, cool. You know, and what ends up happening is, you know, they then come down here and guess what they do? You know, they log in, they create a new set of IAM credentials. They give those back to Robert. Robert updates VRA, and then he uses them. And so this idea of like, what does day one look like versus what does day two look like becomes basically, you know, very repetitive. It doesn't scale, and it takes you just as much effort to do this like the 100th time as it did the first time. So now, to think about this a little bit differently, let's add Vault into the picture instead. So first time, Robert reaches out and he says, "Hey, guys, I need some credentials." And they say, "Oh, okay, yeah, no worries." So they come out to AWS. Do they have to create the credentials there? Maybe, or maybe they just go, "Okay, what's the policy? What are we looking at here? What's the kind of access that you actually need?" So they create an IAM policy. And then what they do is they come over here and within Vault, they go, "Okay, we know a few things. We know that your passwords should only last for 3 days. We know that you should only have access to, I don't know, let's say VPC, EC2, RDS, and S3, for example." And so they basically go and they push that policy into Vault, and they come back to you and they say, "Okay, Robert, you've basically got your access now. Go log into Vault and you'll be able to generate your things." So you then log into Vault, and this is where things start to get particularly cool, right? they haven't actually pushed any IAM credentials into Vault, right? They've created a role. They've basically created policy, call it intention, call it whatever you like. They've basically described the type of access that Robert actually needs, and they've pushed that into Vault. So now when Robert hits Vault and says, hey, I want to get a set of AWS credentials, Vault says, oh, okay. It reaches out directly to AWS, generates that account, comes back to Robert and says, hey, here are the credentials you need. After 3 days, Vault reaches out and nukes those. Now, after the 3 days, by comparison, Robert doesn't have to come back over here to the security team or whatever the team is that's actually managing these. He's just going to come back and hit Vault again, right? So the idea becomes, when we look at automation, do we write something that's, particularly, I don't want to go out and say it's imperative, because you can still do this in like an imperative way, but do you want to actually write the thing that has to be executed all the way through? Or do you actually just want to create, in effect, a description of the target state that you want to get to, and then offload that to a system that has the capability to sort of execute that? So this is kind of like the first model of like the thing that started to blow my mind was, oh, okay, could you generate IAM keys from AWS and store them in Vault for Robert to access? Sure you could, but isn't it a hell of a lot better to actually just say, look, we can offload that whole thing and allow Vault to be directly interacting with AWS, generating credentials basically on demand as required. So that's Robert, right? Another example, and we'll change people here because I don't want Robert to think I'm picking on him. Okay, so this time we've got Michael. Michael's planning on spinning up some stuff. He's got this cool new blueprint that he's working on. I think it's deploying WordPress or something. And he needs, because he's like, oh, you know what, we want to actually, show this in a, slightly more realistic way. And, when I say realistic, what I mean is that we want to actually be generating a certificate. We want to actually be throwing that on the front end web so that when you're coming and hitting that instance, sure enough, we're actually showing you, TLS-based encryption for that traffic. So again, if we look at maybe a typical path, so we're going to have Mike sitting over here. Looks very similar to what we did previously, right? He reaches out to, it could be a security team. You may have a dedicated team who looks after this kind of stuff. It may be like your Active Directory team, depending on how this all works. Reaches out to a team and says, hey, I need a certificate. So they then go to their certificate authority, generate a cert, pass it back to Mike. Now, he then figures out basically how do I sort of inject that into the target system that I'm actually building, and put that in there. So again, you might sort of suspect I'm going to say, haha, well, why wouldn't you actually use Vault as like your certificate authority, and Mike could just, get that certificate directly? You're absolutely 100% correct, but with a twist. Now, the interesting thing here is that, in fact, I'm going to do this in nice big red. Michael shouldn't even need to do this, right? Because in fact, like if we look at anything that's kind of secret or sensitive, the biggest risk to any organization from a security perspective is the fact that, something has to pass through multiple hands, right? You think of like Chinese whispers. You think about, the amount of times that people write things down or, drop it in a notepad on the desktop or something like that, email it, Slack it to somebody. Anytime that you sort of, include more moving parts in a system than you need to, it becomes either complex, unreliable, or insecure. So instead, what we do is go, all right, cool. Yep, we still do need a certificate, but Mike's going to reach out to that team. I shouldn't have quite scribbled you out, Mike, because you still do need to tell somebody that you need this. And what they're going to do is they're going to reach out to Vault, and they're going to say, all right, there's actually, we need the ability to, again, not just request a certificate from the CA and store it with inside Vault, but we want Vault to actually be responsible for reaching out. So they're going to do something like saying, hey, let's create certificates. And since we can auto rotate these, why don't we start looking at bringing down the time to live to something like 24 hours? And now what we do is actually have a little Vault agent sitting on our machine here. It's going to reach out directly to Vault and say, hey, here's who I am, by the way. Here's some information about me. And we can talk about what that looks like. and I'll pause for some questions after this so that you can ask me, that machine can reach out and actually have Vault directly generate the certificate. All right. It'll then read that out. You can render that down to file, and like anytime that sort of updates and changes, if that's only 24 hours, what happens when it expires? Well, we're going to put a watcher in place. And so as we start to approach, the expiry time, we're actually going to trigger and say, oh, let's generate a new certificate so that we don't expire. We'll render that down. And how do we then sort of deal with the application and loading that certificate in? Well, when we actually render it, if we notice a change, we can also trigger a command. So you could do like a system, a service restart. You can write those out to environment variables or files or inject them, whatever it might be. But I think the most interesting thing about this is, while Mike still has a role to play in sort of communicating what is actually going to be required, the consumer that's self-serving in this case actually becomes the machine, right? Or probably more accurately, at some level, the application that's running on the machine. So, again, when we start looking broadly at automation, I think there are things that we've, done for a really long time in terms of thinking about what is it that we try and automate. And we have a very sort of focused view on the thing that we're automating is going to be, machines onto VMware or machines onto AWS. But in fact, like automation becomes this, hugely broad scope. And in fact, it starts to move even beyond something that we need to request or something that we need to push to a set of end users into embedding the automation within, the application or even the infrastructure that the application is going to be running on. So I can very easily keep talking for another 10 minutes, but I'm going to pause there and just give you guys a chance to come off mic and see if there's anything that I've covered so far there that you want to ask about, or if there's anything that I haven't spoken about yet that you'd love to know, and see if I can just sort of freestyle on it a bit for you.
Everyone went quiet.
Tough crowd. Cool. All right.
I have one question.
Yeah, please.
If I may. Once you want to use Vault to store secrets, you always face the question that where is the turtle zero, how you authenticate against Vault. So how you store the initial credentials that you can automate with. What is your recommendation on that?
Gosh, all right, good question. So for those who may not have got that, or maybe haven't sort of looked at this space too much, like you kind of end up in this world of, okay, so I'm trying to connect to Vault or to something else because that's where all my secrets are, because I've put them all in there to make them secret, but I need to authenticate to Vault with some kind of secret. So I still need to somehow be managing and munging secrets and giving access to systems. So how do you go about sort of that initial introduction? So that's kind of called like the secret zero problem, or how do you handle secure introduction for that kind of thing? So what I'm going to do here, and I feel like there's probably a specific area here that we're going to need to delve into, but let's talk about how this is solved in sort of two ways. So the first of which, we can solve this when we have trusted, let's call it trusted platform identity. There's not actually an official term for this. So what do I mean by trusted platform identity? Right, so trusted platform identity is the idea that, in effect, if you're sitting, sorry, my dog's sleep barking. Imagine that this is an EC2 instance, all right? And what we're saying is, that EC2 instance needs to access Vault. So when you've got some kind of trusted platform identity model, EC2, for example, can reach out with its metadata and say, hey, here's who I am as a system. Here's effectively like it's kind of like a JSON web token effectively with a set of metadata that's specific to that machine to say, hey, I want to authenticate. What Vault is then able to do is actually reach back to the AWS Identity Service and say, hey, I've had a request from a system that's claiming that it's this particular thing. It's coming from this VPC. Here's the sequence ID. Here's a bunch of information, and AWS will come back and say, yeah, that's legitimate. And so as a result, then the instance is able to authenticate to Vault. It's able to get access to whatever secret it might be, certificates, database passwords, whatever. So that model works particularly well. The same thing is true across Azure, GCP, Kubernetes as well. The concept of service accounts. When you spin up pods, if they actually authenticate with a service account to Vault, Vault will come back to Kubernetes and validate that particular authentication attempt is actually legitimate. That is far and away the best mechanism that you have to handle something like secret zero and secure introduction. The second way comes into play when you don't have a centralized identity service. And sort of tweeted this the other day. I didn't sort of tweet it, I did tweet it. I think that that's the one thing that remains a gap to have like a fully functional on-premises cloud is the idea of global identity within the data center, right? So that any machine or security group from NSX or whatever it might be has an identity that can be used in this way, that can be verified by vCenter or some other mechanism to handle that. So yeah, when you've got a virtual machine on VMware, then it's like, oh, how do we handle this? So the second thing here is we start talking about what we call a trusted orchestrator, because at some level you've got to sort of begin somewhere, or orchestrator. And you can sort of authenticate a couple of ways, right? So you could use Kerberos, you could use certificates, and we can do some relatively clever stuff as far as that goes. But the way that we typically talk to people about doing this is through something that we call app role. Now, app role on our side is very much like thinking about, how within IAM you kind of got your access key and your secret ID. Within app role, you have an app role ID and your app role secret ID. So the question becomes, how do we go about getting these two things that are kind of like a username and password down onto a system so that it can authenticate to Vault? Ideally, what we want to do is probably like split the path by which these two things go. So you're only ever sort of giving one piece of this to one particular party. And so even if it was compromised, then you've got minimal, or you're reducing your chance of causing a problem there, right? So what could you do? On your initial deploy, you could have vCenter with a script or VRA actually injecting the app role ID down into the target system. And then you could have kind of as your second layer then, config management tool, basically reaching out to Vault, retrieving the secret ID and passing that down to the machine. Now, one thing that we've done as a means of really trying to help to address this problem is when you actually create, this, app role ID and the secret ID, specifically the secret ID, we have this concept of what we call wrapping, which is to say, we'll take that secret ID, we're going to basically obfuscate it, wrap it, and instead of giving you the secret ID, what we give you then is effectively a Vault token. That Vault token is single use and it only has access to one thing. So effectively, when you send Vault this token, what it's going to do is unwrap and return the secret ID. And effectively, that's our means of making sure that even if you do something silly like logging out the secret ID, logging out the app role ID, in effect, what you're actually logging out there is only the wrapped value. So it gets used once and it can never be used again. So again, just sort of looking to try and minimize that. And that's all handled on that side. So those are the two mechanisms that we have to sort of handle the idea of secure introduction. Oh, look at this. Sam McGowan did a talk on app role and secret wrapping, and he's got a talk on it there. Thanks, Sam. So those are the two ways really that we look at it. And yeah, I'd love to see something come into sort of the VMware world from an identity perspective, whereby we could sort of say, hey, here's a machine, here's who I am, here's my metadata. Because this, again, like the other big thing, I'm wrapping up at 2:45, right? Or 2:50, 2:45.
I think you've got about 5-10 minutes left, something like that.
Yeah, sweet. So I think, you know, this is what comes down. The other sort of core takeaway from me, apart from like the concept of what is self-service and who is it that's actually performing self-service, is the fact that in the new world, everything is coming down to identity, because stuff just moves too fast, right? New world infrastructure moves too fast. You know, you spin pods up, you spin pods down. IP addresses are transient. You know, even if you registered those in DNS, it's still incredibly transient. So it becomes, you know, much more important to be able to say, okay, how do we sort of take, you know, something like that EC2 instance, or, you know, potentially a collective of those, and say, right, well, this isn't just one EC2 instance. That's actually an autoscale group that's going to have multiple instances in it. And in fact, the identity of these things is that they're actually, you know, what we're going to call, you know, web servers, for a very generic kind of, you know, easy thing to go after. And then what we do on the Vault side is sort of mapping it through and saying, okay, they authenticate with a unique identity. But we've sort of classified these in a way to say they're web servers. And so, you know, anything that's, you know, coming from this particular VPC, that's coming from this particular autoscale group, we know is probably going to have access to the same set of secrets within Vault. And so identity becomes, you know, a really, really strong thing that we want to sort of manage and look at. So yeah, sorry, long-winded answer to your question, but I hope that sort of helps in terms of understanding that. All right, so what I'll do now, just because I know you probably want like a little bit of, you know, geeky stuff and useful stuff, what I'm going to do is share my screen, and we'll have a look at some code for some fun. All right. How's the size of that?
That's what we're talking about.
The problem is this is, you know, you look at this and you're like, oh my God. So what's going on here? So one of the things, again, like I think that's really, really interesting is when we look at automation and we think about it, you know, there's, from a workflow perspective, there's so many different ways, you know, in this case, to provision a vSphere virtual machine, right? You know, are you going to provision to a data store, or are you going to provision to a data store cluster? Are you going to provision it into a resource pool, or are you going to just, you know, spin it directly to a cluster? There's so many different things that could go on along the way, that trying to create code that's very reusable and that translates across all of those cases ends up being pretty challenging. So what I wanted to do was show you some of the mechanisms that we've got to sort of handle, I guess, handle the broad number of use cases. I've never actually got around to mind mapping out all these different steps. But, you know, some simple things that we can look at that I'd like to delve into. You can see here that I'm using some sort of ternary mechanism, which, let's just maximize that out. Okay, so as an example, to answer the question of, you know, how do I handle this idea of, you know, it has to serve either a data store or a data store cluster. What we're doing is just taking a look at the variables, right? So by default, these variables are set to actually just be an empty string. So I'm going to query those and say, hey, if primary data store remains blank, then effectively I want to go off and query, sorry, if it doesn't equal blank, geez, exclamation mark equals not equal to blank, then what I want you to do is go off and query effectively a data source that we've got set up that has a key value of primary data store. Otherwise, we're just going to set this attribute to null. So basically, we're not going to use the attribute. So what we're doing there is just saying, okay, if you set a value, then that kind of indicates that you probably want to use a data store. However, if you used a data store cluster, or provided a variable for the data store cluster you wanted this thing to land on, then you're probably going to want to use this. And in that case, we're just going to null out the data store attribute. So that's one of the things that we've got as a means of doing this. Another example of things that could change is the idea of how many network interfaces you're going to need when you actually deploy a system. Now, one thing I just really want to quickly point out before I delve further, you're kind of seeing like the back end, what's the word I'm after here? Like this is how you're kind of making the sausage, right? As opposed to the cool eating bit. I'll show you a simple sample of how you can eat this really simply. But what we can do is say, all right, we know that we need to handle the ability to do more than one network interface. So what we're going to do is actually say, look, I want this to be a dynamic block. Now, anytime we try and figure out what that dynamic block looks like, we want to do a for each loop over our networks variable. The content then becomes, we're going to go off and we're going to query, the vSphere networks. We're going to look for one. We're going to look for the specific key name that matches what's in your variables. And we're going to, attach that to whatever kind of network adapter type, which we just sort of default to VMX Net 3 or something similar, right? Same kind of thing starts to apply to dynamic disks, so on and so forth. Then we get into where things get, particularly kind of challenging, because not only do we need to handle flexibility at that level around, number of interfaces and things like that to dynamically create the code for us, but we also need to think, oh gosh, okay, yeah, customization, right? vSphere guest customization relies on knowing what our operating system is going to be. So what are our options? Yeah, we could have two modules and sort of flip it and get the user to tell us what's going to happen. Instead, we're checking here what this like local Windows value is. So locals are a way for you to basically describe something complex and then just reuse a really simple kind of mechanism for this throughout. So that if I wanted to change that attribute, instead of having to come through and change, local host name everywhere, I can just, change the local variable for that. So what are we doing with these local variables? So what we're basically doing is having, a look here, and we're saying, as long as, the template value hasn't been set to be 0, because in that case, we're using a VApp and this is irrelevant. What we're going to do is this really complex thing, right? And what we're doing is we're just taking a look at, I'll break it down. We take a look at the virtual machine template source that we're actually going to be using, and we're going to take a look at the guest ID attribute. We're going to do a regex and see if it starts with Win, because funnily enough, all of the Windows, all the Windows guest IDs all do happen to start with Win. And we're just going to make sure that, as long as we get a regex that matches that, and regex all is a way for us to do that without it erroring if it doesn't match. So that we just have to handle that out. We set that to basically be the value. Otherwise, we set this as null, right? So basically what we're doing is saying, yeah, in the case that it's that, we're basically just evaluating this thing here, and we're saying Windows, the end result of this is either going to be true, false, or null in the case that you don't actually provide that particular value. So the reason why this becomes interesting then is although we've had this like really big expression up here that we've used as a means of saying, hey, this is it. This is the way that we want to evaluate it. When we come down here, we can just do something really easy and say, okay, let's have a dynamic blocks for Linux options, dynamic block for Linux options. And if it happens that expression that we create at the top is false, then we're going to create, basically something here that's not empty. That's all we're doing there, is making a not empty set so that we can create these objects. Otherwise, down here under our dynamic Windows options, if that local Windows expression actually evaluates to true, then we're going to make use of this one instead. So this really creates the mechanism by which the code becomes a lot more dynamic. We can do some other things, right? Like going through and looking at whether or not the IP address is set to be DHCP. Otherwise, we can split out a network value, etc. There's an awful lot of things that you can do in terms of how you handle basically the multiple flows and say, this is how we qualify that this resource needs to be created or this attribute needs to be created. Now, you're going to look at this and think, God, this is complex. And you know what? It is. This is complex. Like, the fact that a virtual machine can be created in so many different ways means that this resource is actually probably the most complex one that I've ever seen in Terraform. Not to say that like in a bad way, like it's just that's how flexible that creation process is. And so as a result, then there's an awful lot of conditions that you want to handle. Now, the good news is once you've gone about creating this, or once maybe someone else has created this, the way that you can go about consuming it becomes really, really simple. So here we just basically say, I want a module, and I'm going to call the module, going to call the module my awesome VM. And the source that I pull it from is just here, right? So I've basically just got this module published on GitHub. That's where I use it. Here's the totality of what I actually need to provide in terms of inputs to consume this or reuse it, right? And this is where the power of the idea of someone who has a really solid understanding of the target platform or the target technology that you're trying to interact with, they're able to create something that's really flexible, really powerful. But then when it comes down to the people who want to consume it, all you need to do is effectively this. And I think that again, is just a really good thing to take away, which is the complexity never disappears when it comes to automation. But our jobs as professionals is to sort of, try and take on the load of that complexity and provide people with a really simple means of consumption, whether that's via, committing some code into a version control system and making a pull request and having that trigger if you want to sort of, DevOps it, air quotes intentional, whether it's, wanting to stick a, portal in front of it through something like ServiceNow and give people the user experience they need and expose these values here in a form, with some drop downs or something, right? Like, I think the thing is not to get hung up on the technology itself, but always keep that focus on, what do we want the user experience to be and how do we create something that's sort of delightful for people to use? And finally, realize that within every organization, within your own organizations, what you're going to find is this breadth of user experiences. You're going to have really advanced people who want to be creating this stuff and interfacing sort of, this way. You are going to have people who want that portal-driven experience. Nobody is wrong. Everybody is actually right. And again, the goal is support as many of those workflows as you possibly can, because that's how you actually get people to work within the systems you build. You give them effectively the user experience that they're looking for. All right, I believe that's going to be time. I will pause there. And just see. Oh, yep. Michael telling me I'm going to need to wrap up. So that's.
I was going to say, yeah. Unfortunately, we are out of time there, I think. Any final questions for Grant at all?
Awesome.
Cool.
All right, guys. Thank you so much for having me. It's been an absolute pleasure.
Thank you so much for coming on, and hope to catch up with you again at a slightly more reasonable time. For you, anyway.
Deal. Sounds good. Sounds great, man. All right. Thanks, everybody. Have a great afternoon.
Cheers, Grant. Thank you very much.
Right. Next up, we have Krisztian. Are you ready, Krisztian? Does anyone want to take a quick break, or are you all fine to push on ahead?
I'm ready. Yes.
You're all ready. In which case, the floor is yours.
Thanks for inviting me to the meeting, and thanks for accepting the presentation I'm going to share. I'd like to talk about VRA integration with ServiceNow. Let me share my screen real quick. I hope it's visible.
Yep,
Can
we
you
can see
see?
that.
Can you see
We
this
can.
presentation? Oh, sure. Cool. So a little bit about myself first, because I don't think anyone knows me in this meeting. So my name is Krisztian Kuklis, and I work for NTT as a IT architect. My roles are, or my tasks are mainly consultancy, architecture, and also implementation. So it's broad set of tasks, I would say. I spent the last around 6 years in the cloud and automation field, mostly with private and hybrid cloud projects. And I started my journey, this cloud and automation journey at HP, and then I moved to NTT later on. And I think that's all about me. And let's jump into the actual content. So first of all, I would like to talk about IT service management and why is it important, and why do we care at all of ITSM. The customers I worked with mainly enterprise customers, and they already have a huge set of rules and processes, policies, and so on. And they are in this ideal world. And when they want to get a little bit speed up, and they want to automate stuff, many times they require to adapt the automation, to adapt our solutions into their existing environment, into their existing policies, processes, and so on, because they want to keep the control. They want to keep their processes. And when we implement something that is automated, for example, a private or a hybrid cloud solution, then they want us to implement it in a way that it fits into their existing processes. Usually they have software tools that supports the service management, and those tools can be very different. There are a few of them which are really widespread, but there are some less common solutions as well. Most of the tools support, first of all, the industry best practices, which is defined by ITIL, and they also support tailoring, so custom solutions can be developed as well. Today, I'm going to talk about ServiceNow. It's one, I would say, it's one of the most widespread solution. It's a leading solution, and of course, it implements the major ITIL requirements, like it supports service requests, changes, incidents. They also support workflows that can manage the state changes, the approvals, the stakeholders, and so on. And it also It also includes a configuration management database or CMDB, and supports reporting. ServiceNow is operated as a service. It's so if someone wants to use ServiceNow, he has to purchase a subscription, and the service is running via the public internet. So it's a software as a service. It is also a platform as a service because it can host custom developments, but for us today, we will use only the SaaS implementation. So the out-of-box functionality, I would say. Regarding vRealize automation, you may think that why we are trying to create something custom when there is a existing integration for vRealize. It's called VMware vRealize automation for ServiceNow ITSM application. This solution basically imports our VRA catalog items into the ServiceNow platform, so any ServiceNow user can request VRA catalog items, and of course within ServiceNow we can create custom workflows around those catalog items, like approvals. Our customers who we worked with, they wanted the opposite. They wanted to integrate ServiceNow with vRealize while keeping the user interface being used by the customers. So they log into vRealize self-service portal, and they want to integrate the solution to ServiceNow. So that's why we will develop or implement a custom integration instead of the already existing one. And a little bit of history. In vRealize 7, we had this external approval support via event subscriptions, and this allowed us to start a workflow, a VRO workflow, and that workflow could decide via any background activities if a certain request is approved or not. For example, it could connect to ServiceNow and check for approvals, but this is not available in vRealize 8. We only have internal approvals at the moment. So we started to think about how to create a workaround on that, and how to solve the problem that we want to approve, or the customer wants to approve certain requests in ServiceNow while the user interface is still vRealize. And here is a approval diagram that we are going to see in the demo. So the sequence goes like, we have a user, and this user will interact with vRealize to request a deployment in this case. So we will demonstrate the approval on deployment requests. And what we will do is we will initiate a VRO workflow at the time of the deployment request, and we will open a service request from VRO within ServiceNow, and this service request needs to be approved. So it's a service request that requires approval. So we need to choose such a service request, And also at the same time, we start a VRO scheduled workflow, and that scheduled workflow will check in the background if this particular ServiceNow request is approved or rejected or still in a pending state. On vRealize side, we set up a service account, and this service account will be a user, and this user needs to approve internally within vRealize the deployment request that the user initiated. The reason for creating this is that we want to inform the customer via the user interface that we are waiting for an approval. So if we don't have this internal vRealize approval implemented, we just start a workflow that will check ServiceNow forever until this particular request is approved. Then the end user will see that his deployment is stuck, so he doesn't see any progress, and to confuse the user. He will not understand why the deployment is not progressing, why it's just keeps working. So we, as I said, we have an internal service user, and this service user needs to approve the vRealize deployment request. So our end user will see that, okay, there is an approval needed, so he will wait for that. And as I said, there is a background process running on VRO, and this background process will poll ServiceNow, will check the status of this service request until an approval action is made on this particular request. And once a decision is made, either approval or rejection, then then VRO will approve the original vRealize request via API using that service account, and will let the user request either to progress or to stop, depending on the result of this approval within ServiceNow. And also we need to make sure that our background polling is cancelled, because we have a definite result of the approval. So we don't want to check rejected or approved service request in ServiceNow forever. So these are the main activities that we are going to see, and let's see how it goes in practice. So first of all, I would like to show you how one can start experimenting with ServiceNow. They have a very good developer program, so one can register and request a development environment where you are an administrator. You can customize your instance as you like. You can experiment and so on. So I already registered a development instance here. Let me log in. I should log in with those credentials immediately, but something, let me communicate with ServiceNow. We will create a service user, and this service user is users we have. I already created this as vRealize service user. Will be used as the user that we authenticate against ServiceNow. And with ServiceNow, we have a REST API. ServiceNow uses basic authentication against this API, so it's very easy to implement it in VRO. So we will authenticate against ServiceNow with this particular user. And in order to have any approvals, we need a service request that requires approvals. So let's see what approval rules we have. I'm going to set up a service request very quickly for demonstration purposes, just with the default set of this development instance. So this instance has a rule that if a particular catalog request costs more than $1,000, then it will require a approval. So in order to trigger an approval, we will create a catalog item that is more expensive than $1,000. So let's see what items we have. So what we will use is, there is a default catalog item called VM provisioning. And this VM provisioning is free. So we will make it a little bit more expensive just to make sure that if someone requests it, then the service request itself will need an approval. Also, I'm going to add some input to the service request, like description.
Looks like we might have lost Krisztian there. So give him a couple of seconds to see if he's able to rejoin. That's a funny comment, Lewis.
I'm sorry, I got dropped. Are you still with me?
Yeah, we're still here.
Okay.
Your video had frozen for a while, so yeah, did
Sorry.
wonder if you're having internet issues.
Sorry. So I just created this catalog item, and I requested it, and right now it's in a waiting for approval state. So if we check it, the requests, here's our request, and you can see the request state is pending approval. And there's this guy who can approve it, and we have a request item within the service request with all the data that we entered, like what was the description, who is the primary contact, and so on. Okay, so we will have the same thing via REST API. So I already...
You might need to reshare your screen, by the way.
Oh, I'm sorry. Forgot that.
Cool, got a terminal there.
So I already prepared this request with all the data that is required. So each catalog item has a unique ID called sysid within ServiceNow, and the parameters are like we need to specify the amount and the variables. I just shown, like who is the primary contact, what was the cost center, the business purpose, the number of CPU, RAM, storage, and the extra variable description I just defined. So if we ran this command, then we will get back a request number, also a sysid, which is a unique ID within ServiceNow. So if I go back to requests, I will see that I have a new request which was opened by our service user with all the data in the request item, like my description, the service account, the cost center, business purpose, and so on. So this is how we interact with ServiceNow via the REST API, and this is how we will open our service request within ServiceNow. Another interesting okay, so this is how we open the request, and we also gonna request the state of the of our service request. For that, we need to specify the sysid we got back, and we will see that the REST API will return from the service request table the actual data on the service request, and we will check this request state, which is in requested state at the moment. So our workflow will verify based on the sysid, the request state, and it will decide if the approval happened or not. So let me approve this request now. And if I check it again, then I will see that it's in progress. So we know that this and the approval happened, so it's already approved. And with our workflow, we will check the approval, we will check the request state, and based on that, we will be able to decide if the service request was approved within within ServiceNow or not. Okay, let me go back to my browser. I will log into vRealize. First, I will show you within Orchestrator how the integration is configured. There are two endpoints configured. One of them is a REST endpoint. So as you can see, I have the ServiceNow instance URL defined here, and authentication is basic with our ServiceNow service user. And we will also need another endpoint for approving our vRealize internal approval from VRO within vRealize. And for that, we will use the vRealize plugin for VRO. This is available since vRealize 8.3, and it's included in 8.4, I believe, by default. And I created a endpoint for our integration user, and this endpoint will be used to approve our internal vRealize approval. As you can see, there was a REST endpoint here I used before when I first developed this solution. I believe it was 8.1 or 2. Then we didn't have this plugin, so I had to go through the REST API of vRealize, which is a little bit more complicated because you need to take care of the credentials, tokens, and so on for authentication, and it's much easier with this new plugin. So it's, the code itself is updated to reflect that. Okay, let's see our workflows. What we have. The first workflow is this approval request. This workflow we run at the deployment request phase, and it will create a ServiceNow service request, and also is responsible for scheduling a task within VRO, a recurring task, and this task will run in the background and will poll ServiceNow and check the status of our service request. So basically, we will start this workflow, this catalog VM provisioning this pause now and approve VRA workflow. And this workflow is responsible for checking VRA, checking Snow, and once it finds out that the approval is made, or the decision is made within Snow, then it will make the internal approval within VRA. It's only for demonstration purposes. This workflow will run every minute, which is more than likely too frequent. So if you want to use that in production, then it's better to use a larger time frame, because this can really be too frequent for in case you have a lot of requests, and then you will have a lot of background processes and a lot of API call against ServiceNow API. So let's check this other workflow, which will run in the background. First of all, it will verify if the approval itself already exists within VRA, because it takes a little while to get into a state when your deployment is in waiting for approval state. And if it's already approved, then we simply delete the scheduled task and exit. And if it's not, then we will check ServiceNow, and we will check if it's approved already, or at least decided. So it may be approved or rejected. And based on that status, we will make the internal approval within VRA, and then we will delete the scheduled task. If it's not decided yet, if it's still in requested state, then we simply quit, and in the next so we check that if the status is approved or rejected. If none of them are true, then we know that, okay, somebody still needs to go into ServiceNow and still needs to decide if it's approved or not. Okay, so how to continue? We have so first of all, we need to create a event broker subscription within Cloud Assembly. And this subscription will trigger our workflow, will create the ServiceNow request. This request will run at the phase of a deployment request, and we also make sure that only in the event of creation we want to run this. Are you still with me?
We lost Krisztian again.
I'm sorry, I lost you again, and I'm not sure
Think we might have lost you.
where to continue. Should I continue or?
Well, yeah, we're. I think we're getting close to running over, so we might need to stop you there, unfortunately.
Okay. Okay. Sorry for the technical issues.
That's quite all right. It can happen. It can happen. Right. Thank you very much, Krisztian. Indeed. Any questions for Krisztian? Cool. Thank you so much indeed. Yeah, very interesting topic. I don't know a lot about Snow myself, so good to see the work you're doing with it. Right. Our final slot of the evening is reserved for Katarina. Good evening, Katarina. I didn't quite hear you then. You're unmuted? Yes.
Yep. Can you hear me fine?
I certainly can.
Okay.
Excellent. So over to you.
Okay, well, thank you very much for having me. I'm very excited to do this. Before we start, I would just like to say this session is really talking about the basics of Kubernetes. I've seen a lot of rock stars on the participant list, so I know there are people who know a lot about this topic. But the intention with this one is really to present for people who maybe are just starting with this topic or are just even thinking about getting into this space. So let me just start my presentation. So in terms of what we will be doing today, well, we will just do some basic introduction. Then we will talk about some Kubernetes basics. We'll talk about the tools that we need to get started. And then the most interesting part, we'll do some little demos and obviously we'll do them live. So just to start, I would like to explain.
You're not sharing yet.
Oh, sorry. Ooh.
No worries.
Okay. Should.
Yeah, there we go.
Sorry about that. Okay. So that was the inventor. So to do the introduction, I would just very quickly want to talk about why am I doing this and what I am doing. For most of my career, I have spent 16 years in IT. I have stayed in infrastructure-oriented roles, such as I started as a Windows admin. I then moved on when virtualization came about to work in VMware, became an architect and a consultant. But I was never really a developer. And I always found it very daunting when I was trying to learn new things that were so outside of my scope. Because what you are usually faced with is a lot of new terminology, a lot of new tooling, and you don't really know where to start. So what I wanted to do was to create a step-by-step guide that anybody could follow. This is what I have done on my blog on advacti.io, where I have so far recorded my journey and working with Kubernetes. Why I decided to do this as well was that I wanted to create something that had a little bit of substance and also to motivate myself to make sure that it actually runs rather than just creating some very simple sample application. I wanted to have an application that I can work with, I can update, I can do changes to, but at the same time, I wanted to be documenting the journey. So this became the ideal solution for my use case. So now we'll just go into the basics of Kubernetes. So this is the definition that you would find if you would go onto the official documentation of Kubernetes. Again, if this is the first time that you are looking into this, it's a very long sentence and it talks about a lot of things. But there are two things I would like to highlight in this. So the first one is, as it says here, we are talking about managing containerized workloads and services. So immediately we know that, okay, we will be working with containers, and that's what we will be focusing on. The second word that's really important in this scenario is here, declarative. I know Grant touched upon this very briefly, but again, I would just like to explain what this means. So when we talk about declarative approach, we're talking about defining our desired state. What are we trying to achieve? And this is what we will be using throughout the whole session today and throughout the demos. On the other hand, we have the imperative approach, where we would traditionally define all the steps that should be taken. So if you have ever written any sort of scripts, could be very simple, you would be usually defining for all of these objects, do this, and you would define every single step. So that's the major difference in here. And as I said, we will be focusing on the declarative approach. Moving on. If we talk about containers, I think it's really important to take a step back and think about how we got here. So we all started, well, majority of us started in the physical era. So during these times, we would have some server hardware, we would have an operating system running on it, and then we would have some apps running on that system. Unfortunately, this system wasn't great and was causing a lot of problems with inefficient use of resources. You usually ended up with two scenarios that were polar opposites. Either you had a server that, because of cost savings, you tried to run every single application you could think of on. So you ended up, for example, in Windows world, you ended up with servers running your Active Directory, your SQL servers, your Exchange, and everything on one single box that was overloaded and usually crashed. On the other hand, you had physical servers with, let's say, 4 gigs of RAM, just running a simple web server. So most of the time, the server would be doing absolutely nothing. So not only was it difficult to manage these systems, but they were obviously taking up a lot of space in the data center. They were prone to hardware failures, and there was not really much we could do with them. That's when the virtual era came in and virtualization became a big thing. This introduced another model. So you would have the same hardware, but on top of that, you would run your hypervisor operating system. And on top of that, you would run your virtual machines that would have operating system and then again, some applications running on top of this. This addressed the resourcing massively because suddenly you could use one physical server and run loads of virtual machines on it. So that provided better maintenance, better scalability of your applications. It also, with introduction of tools like vMotion, we were able to do maintenances without downtime. If we had hardware failures with HA, we could react to that and servers being restarted. So it really made our life much easier. And now coming into the container era, well, it's not specifically defined. We are slightly changing the focus. So again, we would have our physical hardware that would run an operating system. On top of that, we would have our container runtime because we're running containers. And on top, we would have these really small, lightweight containers that would traditionally contain one application, just to keep everything decoupled. This means that they would not be really reliant on the infrastructure they run on, so they are very agile, they're very quick to spin up. So even compared, talking about physical servers, old ones, maybe boot up system of a Windows physical server would be sometimes 20 minutes. Virtual era came with a minute or two, and with containers, we're really talking about seconds in a lot of cases. So the other advantage of this, that they are portable, but at the same time, they are very consistent. This means that it doesn't matter whether you run a container on your laptop or you run it in the cloud, the end result will be the same. So that is one of the greatest advantages. I will now briefly touch on components of Kubernetes. And when we talk about this, we talk about Kubernetes clusters. I will not go into the details because that is not the intention of the session, but there are a few things that I would like you to get the understanding of. So our cluster is composed of two major parts. So the first one is control plane. So these are your master nodes that are basically responsible for all the management, the scheduling. They handle all of the cluster events, so things starting and stopping. And they contain multiple bits, but the one that is really important to be aware of is called the Kube API server. And this is the only thing that you actually interact with. So you send your commands off to this API server and it handles it for you. And then the other bit are the worker nodes. So these are the nodes that actually run our containers, run our workloads. They have a little agent running on them called kubelet. And again, this is then responsible for the communication with the control plane. The other thing running, as I briefly touched on before, is the container runtime engine. There are various different types. Probably the most known one, and the one that I will be using in my scenario, is Docker. So we will be doing that. So I really don't want to talk about theory much. So let's just talk about what we need to get started. So we will need a few tools. Again, I think these tools are great for beginners because they make it so much easier to start. So I'm using these as well. So the first thing you would like to install is because we're using Docker, we will be using Docker Desktop. So this will help you not only to have all of the Docker tools available, but it also contains all of the Kubernetes stuff that we will need. In this scenario, we are using Hugo to generate our static content for our website. So we will install that. I mentioned also GitHub Desktop that I have installed, and that's because we will be using Git again. Don't worry, it's just one command we will be running, nothing major, but it will be nice to have all of the tool sets available. You need some sort of terminal, so I'm just personally using iterm2 on my Mac. We need to edit text files. So I'm using Visual Studio Code. You can use any text editor that you prefer. And then and I will explain the reasons a bit later, but because of some functionality, we will be running our Kubernetes in a cloud. Now, there are various options you can go with. You can do AWS, you can do Azure, you can do Google Cloud. I believe also DigitalOcean does one, but my personal favorite is Linode. So I will show you very quickly how easy it is to deploy a Kubernetes cluster on Linode. And again, this is great for people who just really want to start. With your Docker Desktop, it's worth mentioning that it runs a local version of a Kubernetes cluster called Kind. So some of the things you could try, but if you want to use all of the tasks and features that we will be talking about today, it's nice to have it deployed in the cloud. But it is very, very simple and it's not extremely expensive. So the first thing we will do is deploy our cluster. So I will quickly just switch onto my Linode. So all you will have to do is create an account, and then you will just log in, go to create, you will click on Kubernetes. You will define your cluster name. So I have chosen Automation User Group Demo. You can select from different regions. So my region is London. You can select the version. So the latest they have is 1.21. And you can then define what you want. To be honest, for testing purposes, you are okay with just 2 nodes. And as you can see in this example, it's $10 a month. So it's not too expensive. So you can obviously later on, you can choose different configurations, but really to test the beginning, the small steps, the 2 gig nodes and 2 of them is enough. So you would just click add and you would go on and create a cluster. I have already prepared this just because I did not want you to sit and wait, but it only takes a couple of minutes anyway. So ignoring the first one, that's the my production cluster that runs my blog. So we will not be touching that. But here's our new cluster that we have created. The second step you would need to take in this scenario is just to download your kubeconfig. So you will need this file to tell your machine how to communicate with your Kubernetes cluster. So I will just show you, if you go into the cluster view, you can see your nodes. So I have 2 nodes defined here. And this is how the file actually looks. So it just defines the clusters, the user you will be using, also with the token and context. So all you would have to do is now take this and copy the contents into a file that's called config. Now, if you are on a Mac, this will be in your home directory in .kube folder. There will be a file called config, or you can create it with this information. I believe on Windows, again, it is in your user profile and then a similar path, but all the information is available in the documentation. So once you have updated this, you are ready to start working with your clusters. So I think that's the interesting bit, and that's where we want to go. So we have several steps to go through. I will just see how we are doing on time, but I will try to, as I'm doing these steps, I will try to explain and guide you through what I'm doing. All of these steps are also described in the blog, so if you want to repeat them, you will be able to. Okay, so if I now switch onto my terminal and we can start. So the first thing we need to do, as we described, is we are using Hugo. So after you have installed all of your tools, we now need to create our website. So if you don't have much experience or any experience with Hugo, don't be worried. It's very simple. Also, what I will be doing is very simple, and I will show you all of the steps. So the first thing we will do is Hugo new site, and we'll just give it a name. Congratulations, your site is created. It's really interesting how simple this is. So I have created a site in my folder where I want to keep all of these files, but you can choose your location. The only thing you need to do now is to go into that folder. Okay, and now, as I have mentioned before, we have also GitHub desktop installed. We need to run a git command to download a theme for our Hugo blog. So there are very few steps you need to actually do with these blogs, but when you go on to their official site, you can select the theme, so how your website will look, and then you just need to clone it onto your repository. So I do have a little cheat sheet of these commands just so I don't have to type them all in. So we will just paste it here. Okay, so we have now cloned all of our data, and we will also open a new location that will be in GitHub. It will be our demo. Okay, so this is this is what we have now created. So in our folder, when we created the Hugo website, it created some of these contents, and then when we clone the theme is actually in here in these folders. So one little step we need to do here is just to change the config.toml file. Again, I will just quickly go to one I prepared earlier. And again, this is described on the theme. But all we will do here is just say what our URL is, and we'll leave it for now. Our title, so this is what we will say, and this is the theme. So we will just save this. Okay, and now if we go back to our terminal, we just need to create a new post. So we will do Hugo, a new post, because that's the where our posts are located. My first post.md. So Hugo is using markdown files. So this will be created. And the fantastic bit of this is that now we will just run Hugo server and we can render our site locally. So we are immediately able to see what we have created. So if I go to my browser and just go, so I'm going to my local host. This is the website we have just created. Now it is not running anywhere yet. This is just the rendering of how it will look. So we have completed the first step. Now we have this created, but now we need a container. So the next step we will do is create a Docker image with this. So to do that, we need to create a Docker file. I will, again, just show you how it looks. So we have a Docker file here. I will just copy this over because the intention of this session is not to really talk about Docker, but it just defines what we are installing. So we're using Alpine Linux as a base. It's installing Hugo version 81. So it installs Hugo, it copies content from where we are. So you've seen that we are working in this directory. So it will copy it to another folder, and then it will create those files, run nginx, and expose it on port 8080. Again, all of this is available, so you don't have to remember any of that. So we now save this and go back in. So now we will start using our Docker command. So really, we just need two. So the first one, we will build our image. So we will do build. We will tag it. And I am pointing this to my my repository. So this will be the name. This is my GitHub. Sorry, this is my Docker ID. So I will just build the image. I'm not defining any version at this stage. Oh, sorry. Oh, yes, we need to tell it. What? Yeah, that's better. Sorry, dot for starting where we are in the directory. So we have created our image. And now our next one, we will just push this image. Okay. So as you can see, the default tag that this is using is called latest. So we haven't defined any version. Every time I would update this now, it would just always use the latest tag. So great, now we have a Docker image installed. What we can do, so if we list our images, we are able to see our image with the tag latest created 45 seconds ago. Okay, so now we have done all of the preparation that we needed to start actually working with our Kubernetes. So the first thing we will create is a pod. A pod is the smallest unit Kubernetes works in. A pod will contain one or more containers, but generally it would be one, just to keep it simple. And that is what we need to define. Everything is defined using YAML files. Which means that it is also very, very sensitive. Let me just quickly close this. Okay. And we will now create a new file here. I could be doing this in my terminal as well. I'll just find it easier to do it in Visual Studio. So we will create a YAML file. Again, let me just quickly go to my cheat sheet here and copy it. Don't worry, I will guide you through what I'm putting in. Okay, so we are creating our first definition of a pod. So we are defining API version, the kind is pod. We have some metadata, so we will call this demo pod. This is a very interesting thing, is a label. So we are defining a label called project, and the name is automation user group demo. Keep this in mind, it will come in handy later. We will also define our container. So this first bit really is the definition of the pod. This here is defining the container. So the name of the container is, again, you can do whatever you want. So I use the demo dash container. The image will be the image that we have just created. And again, the container will be exposed on this port. So if we save this, now we can start deploying things. So just to make sure that we are connected to our cluster, I can do kubectl, which is the command that we use to interact with the API. Remember when I mentioned that? This is the command we use to talk to it. So if I get my nodes, I can see that I have 2 nodes and they are both ready. So just to verify, if I would go back to my cluster, so we have 6E and 55. And if I go here, we can see this is 6E and 55. If you have multiple clusters, you can use them. You would just be switching context. I don't want to go into it. Very handy feature. If you use Docker Desktop, you can actually switch using the application itself, which is pretty neat. Okay, so let's deploy our first pod. So we'll do kubectl, create, we define the file, and it's pod.yaml. Okay, and if we now do kubectl get pods to see what we have deployed, we can see that we have 1 pod running and it's in the ready state. So it's 6 seconds old. That's great, but we need to create something to interact with this pod. And this is why creating a cloud-hosted Kubernetes cluster is handy, because it gives us the ability to use load balancers in the cloud. So that's the next step that we will do. So we will define the load balancer. So we will create a file that will be called cloud load balancer.yaml. And again, so these are predefined values you will find in documentation. So the kind we are doing now is service. We again give it a name, so demo. It will be a load balancer, it defines the port, and this is the selector. So remember the label I talked about that we have defined here. We are telling this to use that same label. So we will save this. And again, kubectl will become your best friend when you're working with Kubernetes. And we will create that service. So we call it cloud lb YAML. So it's created. So if we do kubectl get service, we should see our load balancer here with our IPs, and this is the external IP that it is getting. So if I now quickly go here, in a minute, this should become available. And there it is. So we have deployed our first pod. We have exposed it using a load balancer, and we can now access it using our external IP. So this is the block we did. That's fantastic. But we have only deployed 1 pod. So what we can do to demonstrate what would happen if that fails. So going back, we can run a command kubectl get pod with output wide, and this will help us to see on which node our pod is running. So you can see it's running on the B5 node. So if I switch back to my cluster, this is the node. I will now simulate a node failure. So this is 55, and I will just power it off. Okay, we'll give it some moments to shut down. Okay, just a few more minutes. Almost there. Okay, it's offline now. So what we can do, I can check my node again. And we can see that second node is now in a not ready state. If I look at my pod, you can see my pod is not ready and it's shut down because the host is off now. Similarly, if we go to our website, it should be there. Right. So that was just showing how we create pods and service and what happens when we accidentally shut down a host or if it fails, and what to do to prevent this. So going back, we will now introduce something that is called a deployment. A deployment gives us an option to define how many versions of our pods we want to be running. So again, it's a YAML file as it was before. So I will just take these and create a deployment YAML. Okay. So it is deployment. We will give it a name. We will give it number of replicas. So replicas are the number of pods that you will be running. So in my case, let's say 3. The selector again needs to match. So let me just quickly change it. Okay, interesting thing to note here, under the specification of the container, we have defined image pull policy always. So it means that every time it creates the container, it will pull the latest version of the image. So we'll just make sure that the image name is actually correct. And we save this. And if we go and create this deployment, it should be created. And now if we do our pods, we can see that our deployment is creating. Okay, so now we have 3 pods running in our deployment. So if we go back to our website, it's back again. And if you have noticed, I did not have to change the IP because we created a load balancer that defined where to find these pods using those labels and selectors that we have defined. A very quick way of checking this is if we run kubectl get endpoints. This will help us to understand what endpoints are defined for that service that we have just created. And if I run again kubectl get pods wide, I will be able to see the IP addresses, so I can see that they match. So I have my 137, 138, and 139 in here, as well as here. So this is why using the cloud load balancer is a fantastic way of not only exposing your application, but also as you are making changes in the background, it will just look at the selectors and the labels and use that. So that's great. Next, I'm conscious of the time, so we will run through a few more steps that I think are interesting. So the next one is scaling, and this is really one of the greatest things that you can do very easily. And that is to define how many versions of your application you want to be running. Again, everything we are doing, if we go back to our deployment, so for example, in this case, I can just do it from my terminal. So if I just open my file, I can go in and change the number of replicas to 5. And as soon as I write this down, and I will apply this because I'm making a change to my deployment. The warning is only displayed because I have used create before when I was creating it. If I would have used apply before, it wouldn't be displayed, but the configuration was still done. So now if I look at get pods again, we can see that now we have all of these running. So that's great. We have scaled up our application to 5 replicas. It's very easy if I want to go the other way. So if I define like, okay, 5 is too much. I now want to go to 2. So again, I will write this down. I will apply my change. And you can see now it has been configured. And if I run my pods again, you can see some of them being terminated, and we should be, in a few moments, be left with only 2 running. I'm just giving this a okay, now it's back. One thing I will do as well, just make sure I power on that node again, because we don't want everything running on one host. Okay, so while that is starting, the next step I would like to show you. So far we have created our Hugo website. We have created our Docker image. We have deployed our pod. We have exposed it using a load balancer. We have defined our deployment, so we have multiple replicas. And now what happens if we want to update this? So I want to make a change to my application. So what I would do is, again, use Hugo to create a new post. So I would just do Hugo, and I would do new, and I would do post, my second post.md. So it was created. Again, I can run Hugo server, and I can just quickly go check that everything looks as I wanted it to. So we can see, again, this is the local rendering. We will have a second post. We can even go, let's say, into our second post in our content and just do and we save this. So I have now created a second post. So effectively, I have made a change to my application. As soon as I saved it, it detects the change. So now if I get out of this, what we need to do now is to update our Docker image. So again, I will run the same commands. So Docker image build, build But what I will do now is I will define a version. So before it was using the latest tag, now I'm using 1.1 version. So I'm building a new image. Now, if I run Docker image push, I will push. Okay. And if I do Docker image list grab, so just to filter out my images using the name, I should see my both versions. So I can see the 1.1 version created 13 seconds ago, and also the latest version created 16 minutes ago. So now what I need to do is in the deployment, I will add few lines just to define what my update process is. So if I move this a little bit, and I want to open my test. So I will just go into my image, and in my specification of my deployment, before template, I will add few lines. So Minimum ready seconds means that it will wait 10 seconds until a pod is ready before it proceeds with the other one. My strategy will be a rolling update, so it means it will go through all of them. And I'm also defining how it should do it. So max surge 1 and max unavailable 0 means that there will be no downtime to my application. It will basically deploy one extra pod with a new version, then delete an old one. Deploy another one, delete an old one. So if I define my number of replicas, in this case as 2, it will keep the same level at all times. So that's fine. And now the other thing I need to change in my deployment is defining the image. So I will just add my version here at the end. So I save that. And now if I do kubectl apply f deployment YAML, I have configured this. And if you're fast enough, you can run a command that shows you the status of your rollout. I had to be very quick because I only had 2 replicas defined, but basically you can see what the process is and what's going on at the moment. So we'll just give this a moment to finish. Okay, great. So if I do get pods, I can see that again, we're down to 2. It's terminating these because we were playing with the numbers before. But these are my 2 deployed new instances. And if I run another command, which is kubectl describe deployment, and again, I'll define the name of the deployment I'm talking about. You will be able to see that in my deployment, I have 2 replicas desired and 2 updated. Everything is available as it should be. This is my strategy that I have defined. And you can see the image it's using now is version 1.1. Also, if you scroll down, you will be able to see the latest actions that we're taking in this deployment. So this is great. We have updated our application. So if we go on to our application, we now see our second post. So everything is working. We have verified that everything's fine. But what if it wasn't? One of the last things I'll show you, because I know we're running a little bit late, is how would you roll back this scenario? So if I just go back to my deployment, what I want to show you is that while we run this update, it doesn't necessarily mean that what we were running before is completely lost. If I look at our replica set, you will see that this is the new deployment that we have deployed with 2 desired pods and current 2 ready to, but this is the old one. It's still there, so it gives me an option to roll back. So what I will do now is I will run another command which defines to undo the rollout, and again, undo deployment, and we specify the name. And if we are quick enough, rollout status. So again, the same command, we should be able to see what's going on. So we'll just give this a few moments to complete. Okay, so it's successfully rolled out. So if I look at my kubectl get replica sets, again, you can see that we are now running on the original deployment. The other way how we can define or verify that we have actually successfully rolled back in our command line is again run kubectl describe deployment demo deployment, and we can see the image version has changed back to the one without our version defined. So this basically concludes what we have created. Before I leave you, just some best practice. If you are really just running tests, it's always a good idea to clean up after yourself. In this scenario, you are paying for the cluster, so theoretically it doesn't matter what you're running in there, but you may end up in a situation where you will forget about some deployments defined somewhere, and you will be wondering why there are pods coming from somewhere and you don't know where it's coming from. So we have created 3 things. So just to clean up, we will do the same. Before I do, let me just quickly go back and verify just to show you that we have successfully rolled back. So we are back to our first post on our website. So everything's great. So we will just do kubectl delete. And now we have 3 things to delete. So just to show you. Okay, so we have our pods here. So we will do kubectl delete deployment. Well, let's do the service first. So if I show you, sorry, get service. So this is the load balancer we are running. So we will delete that first. Delete service demo. We'll just paste it there. So that's deleted. So if we go to our website, that should eventually die. So it will no longer be available. I'll just give that a moment. And then if I go back here, I will just delete deployment, and it will be our deployment that demo deployment that we have created. Okay, so if we now run get pods, there are no pods running. So we have successfully cleaned up ourselves. This is no longer available. And that concludes the demo. So thank you very much for spending your time with me. If you would like to know more or follow this journey, please go to advecti.io. I try to update the content regularly and add new things, so you will be able to follow along. If you have any questions, please feel free to reach out on Twitter. My Twitter handle is @Mrs. Brookfield. And if you want to learn more about Kubernetes and the theory behind it, I strongly recommend to visit Kube Academy. There are plenty of wonderful videos and sources to get you from beginnings to deep technical materials. So thank you very much. And that's it from me.
One question in the chat for you, Kat. If you want to check that out. Saves me reading it. I was going to ask as well. I mean, what's next for you in the journey that you've got documented on the website? You know, what's your next step? What you're working on?
That's a very good question. I don't know myself. I'm still trying to cover the basic Kubernetes commands. So I still want to introduce working with different contexts, creating maybe some resource limits for your pods and management like that. And later on, I would like to start introducing really the integration with maybe multiple clusters, working multi-cloud and all the offerings that are available. So there's still a lot coming. I still don't have the journey defined myself, but it will be definitely interesting. So feel free to follow.
Yeah, the question from Lewis was around sort of tools for helping visualize Kubernetes resources while developing locally.
I think that's a question I will have to look into more, but I'm happy to come back to you, Lewis, on that and answer as much as I can.
Brilliant. I look forward to it. Thank you. It's a really good demo. Thank you.
You're welcome.
Any other questions? Going to take that as a no. Thank you, Kat, so much. Brilliant session.
You're very welcome. Thank you for having me.
Indeed. Unfortunately, as I mentioned at the start, we've only got 3 sessions this evening. So that is unfortunately the end. Any questions, volunteers for next time? Thoughts, feedback, anything at all? Everyone's quiet. Okay.
I have a bit of feedback if you don't
yeah.
mind. So I'm pushed to talk, and I always just talk without forgetting to hit the button. You know, you would have thought I would have learned by this point in the year. I think reflecting on the kind of the different versions of this I've attended, I think having fewer attendees go have slightly longer sessions actually kind of works. 3 seems to be a sweet number for, you know, having a decent amount of coverage without kind of being overwhelmed. But I remember, I think the last one, you know, we had was it 4 or 5, and it got quite hard to kind of keep your head around. So I think this was a good kind of duration or number of presenters. I think if you ask for feedback, that's the one thing I would.
Yeah, well, yeah, there's definitely good feedback, and we'll certainly bear that in mind. I think you know, trying to line up people to run the sessions and things like that. Yeah, sometimes you think, well, you know, if we're going to do it, then you know, we'll try and get as many as possible. But that's certainly good feedback. Yeah, we'll have a look at that as we're planning. Definitely. Anyone else? Anything else at all? If not, yeah, we're targeting 21st of October for the next one. We'll publicize it via Twitter and whatnot in the coming weeks. And wish you all a very good evening, and see you again soon, hopefully. And thank you, of course, to Grant, Krisztian, and Kat.
Thanks, guys. That was great. Good evening.
Okay, thanks all. Good night.
Yeah.
Thank you. Bye.
Bye.